Hello. We're going to be working on this constant velocity model representations worksheet today. I have a separate sheet that has a similar setup that I'm going to go through and work on some examples of it to make sure we see how to do some of these different things. I'm going to scroll through this really quick, so you'll notice on question one, problem one, there's a part that's more grayed out, and then there's a part that's not grayed out. That not grayed out part is the assignment for that question. However, you definitely need the other portions to figure out how to do this question. When I scroll down to question two, um, the grayed out portion is a different section now. It's a graph, and we definitely need that graph to answer these other questions. So as you scroll through, there will be some sections that are grayed out and other sections that aren't. Um, which section is not grayed out? Those sections are the ones that we need to work on today. So looking at the example problem, the first thing that we're going to take a look at is the word-based representation. So right now we have a model, the constant velocity model, and we can represent an object with a constant velocity in a variety of ways. We can represent it with words. That'd be the word-based representation. We can represent it with a graph, with a diagram, with calculations and numbers, and then there are some assumptions that we might use. So we're going to go through and work on each of these different types of representations. Um, so this question, we have this cyclist moving along. The word-based representation for this, the cyclist moves at a constant velocity, so the position changes from something to something else linearly or in a line, with changes in time from something to something else. Well, to get these blanks, I have to basically go down to my graph and fill these numbers in. So it changes from something to something. So from is the starting value, and it looks like in this example, we have the initial or the earliest in time. This left right axis is time, so the earliest in time would be 0 seconds. And as I go up, this is the positive direction, that's the negative direction. So if this is 0 seconds, 0 meters, at 0 seconds for this graph, they're at 300 meters. So I'm just going to go up here and say 300 meters. Um, just to make, yeah, forget it. Then, um, so it goes from 300 meters to it ends at 700 meters. So I'm just going to change that to 700 meters. And it does that change linearly in a line with the change in time goes from 0 seconds to 4 seconds. So 0 seconds to 4 seconds. Just getting, oops, and I forgot oh no, Control Z. There we go. I forgot the S up here. There we go, 4 seconds. Every number should have a unit of measure. And so I just got that 4 seconds there, the 0 seconds there, 300 meters, 700 meters. That's where I got all those values. Um, there's a different way that we can do this word-based representation where maybe other values will be given to you. So we can say a cyclist moves at a constant velocity, so the blank changes from something to something. It changes proportionally with changes in time. So we're talking about this being a change in time. The other thing that changes, I'm going to look at my graph. Well, this axis is time. This axis is position with a D. So I'm going to say that its position changes from, and then we can say 300 meters to 700 meters. So the position changes from 300 meters to 700 meters proportionally with changes in time from 0 seconds to 4 seconds. Um, that's it for the word-based representation. Note that we're trying to say that something changes linearly, or there is a change that is proportional to something else. So as the time continues on, the change in position gets larger and larger. That's what we're really trying to do with these sorts of questions. That's it for the word-based representation.